LeetCode Problem number 45, Jump Game 2. So this problem gives us a zero-indexed array of integers called nums of length n. So we are initially positioned at the first index, index 0. So each element, nums I, would represent the maximum length of a forward jump from index I. So meaning, let's say, looking at this index 2, index 0, we have 2. So this 2 would mean that we can jump to either over here or over here. Right? This 3 means that we can jump to these 3 indexes. So the goal is to return the minimum number of jumps to reach the end of the array. Right? Nums n minus 1. And the test cases are generated such that we can reach the end of the array. So that means there won't be any edge cases where we can't reach the end. So this is my approach. Let me just grab a test case. Here, initially, I note down the size of nums. So in this case, size is 5. And we have result. So result is the one that we are going to return as our answer. So the first thing I do, and this is pretty important, is to change nums so that it will note down the maximum number of jumps, or more like the maximum length, the furthest I can jump from this index, for example. Right? So this, for example, 2 here means that I could jump at index. I can jump the maximum to index 2. 3 here means I could jump to the maximum of index 4. Right? So starting with that, my I would start from 1, which is 3. And here, we are looking for the maximum between 3 plus I is 1. Right? So I is 1. So 3 plus 1. And the previous number, which was 2. Okay, I'll show you why we need the previous number in a bit. So in this case, we know that this will give us 4, right? Okay, let me have a initial number. So this is the original one, and this is the one that we are going to update, right? So this 4 means that we could jump from here to the index of 4, right? Moving on to the next index. So here what we are looking to do is plus I. So I in this case is 2, or the previous index, which is 4. Right. So what this basically, oh sorry, this is 3. What this basically means is I could either from this index note down where I could jump from this index specifically, which in this case, since this index is 1, I could only jump to the next index, which is 3, at position 3. Or I could use the previous indexes that brought me further away, for in this case, which is 4, and note that down instead. So why use this when I could use this to reach a further distance instead of coming from here, right? So that was the thought process. So if we note this down to 4, and now we basically do the same thing for the rest, right? So this will again be 3, 4, right? 3, this will be 4, since I is 3, and 3 and 1 plus 3 is 4, so reach 4. So this will become 4. So here you see nums have been converted to now only store from this index which is the farthest I could have went, right? For example. Okay. So once that is done, here in my for loop, I iterate through not the entire list, but by using kind of a I guess you can call it a graph way of iterating. But basically, since I is 0 again, and now we are only iterating as long as I has not reached the end of the array, right? As long as I is smaller than size minus 1. So in this case, I will now become, I guess in fact, so rest will become 1 first. Now I will become the nums I, and for this case, nums I is 2. So if you go to 0, 1, 2, So I is now 4. Right. So when that happens, result will increment. And now since that I is now is still smaller than wait, no, it's not smaller anymore because size minus 1 is 4. So now size has reached the end basically. And once that is done, this for loop will end and it will return the result, which in this case would be 2. Right. Okay, let me show another example. Let's say -1 here, 3, -2, and 1. Okay, so num size will stay at 5, result at 0, and I will now start at 1. Okay, now nums 1, so here we are looking for the maximum plus I is 1, or we could use the previous number which was 2. So in this case, -1 plus 1 will give us 0. Right. By the way, this example will not happen in the official test cases because here it says that j would be more than 0. Actually, it does not be say, yeah, but here I would be more than 0. But let's say if I do include a negative number, what will it look like? Okay, so here, again, -1. So this will become 2, right? We're getting the maximum. So meaning from this index, the maximum length I can move forward is to index 2 over here. Same with index here as well. I should change this one instead. Yeah. So meaning I should have used this to jump here and not go to this place instead. Okay, now I will become 2. And here we do the same thing. Plus I, or we can use the previous number. So in this case, this will give us 5. So the maximum will be 5. So what this tells us is if we were to take on this index, we would be able to reach to index 5. Right, for this case, it is obviously outside of the array, but that doesn't matter for this case. I increments, and we are moving on to the next index. Plus 3, and then we have the previous one, which is 5. So this will give us 1. And looking back again, so this is obviously the index that will bring us further than if we were to touch on -2. I increments, and now we're looking at the last one. Plus I is 4, with previous one is 5, and since both of these are the same, we just put 5 here. Okay, again, this for loop will now end, and we move on to the next for loop. So I becomes 0. Since as long as I has not reached the end of the array, our result will increment. So result increments by 1. Now I would equals to nums I. So nums I in this case is 2. So 0, 1, 2. So I now reaches 5. Result will increment. And then since now I so since now 2, 0, 1, 2, so I has now become more than 5, right? So in this case, this for loop would end, right? This for loop will end, and will return the result 2, meaning we only need to jump twice to reach the end of the index, which in this case, if you look at it, if we jump from here to here, that's 1 step. This is 1 step. From 2 to 5 is 1 step. 5 to the end is 2 steps, right? Okay, So that's pretty much it. That's all I have to show. Thanks.